Yeah, and the Caroline.
All right, kiddos just joining us. Sorry that your PSAT went long. Period 5, period 2, period 5 is kind of in the same boat because they're not going to be able to make it in for class either. So those of us that are in here, we're going to go ahead and do as much as we can so that if you watch this video tonight, it will help you in studying for the test tomorrow. We're starting off with sections 2.5 and 2.6. The people before me have their spirals ready with their colored pens, so that when they turn in their spirals tomorrow, they can get full credit for attempting and for grading, as long as they work on the review. And then they've already asked me if we could go over some of the quiz questions they got stuck on. And they also asked if we could, well actually I brought up, maybe we should go over some of the harder, trickier review problems as well. So I have the book ready. I have my notes ready to do as many examples as possible in our Chapter 2 test review. Remember, Section 2.7 is not on the test, right?
Yep. Yeah.
Good. Section 2.7 is not on the test. So let's come back. Section 2.5, evens. Number 2 is the linear factorization theorem. Number 8, lower and then upper. Number 26, you guys can see at the very end. Really quickly, let me show you the difference. I'm actually going to do it with my mouse so people on the video can see as well. This would be called the factorization or the factors of f of x, right? These are the factors. These are the zeros. Does that make sense, the difference, guys? The factors are written with the parentheses x minus the zeros. The zeros, you set each one equal to 0 and solve. Question, what's the multiplicity of the 0, 3? 1. Careful though. If we were to rewrite this, it would be squared, so then the multiplicity of this one is 2. The multiplicity of this one would be 1. Just reviewing multiplicity for tomorrow. Okay, number 30.
Can you go back then? Sorry.
Oh, number 20?
Yeah, 26.
Yeah.
Thanks. Sorry, I missed that.
So 3 1/3 are the zeros. X minus 3 squared, technically, times 3x minus 1 are the factors. P.S. This is a great problem where they just say to solve for the zeros or the factors. You have to find the different possibilities, find one that works, and then finish off the problem. Okay. Number 30. Super similar, except the problem got a lot easier, not a lot easier, but a little easier if you saw there was a common factor first to pull out. Sometimes there is, do that. And then go ahead and take what's left, check all the different possibles. Remember, you can plug in and check and see if it equals 0, or you can use some like division and check, see if the remainder is 0. You end up with these as the final factors, and you end up with the following zeros that ensue when you set every single one equal to 0. Find the zeros, set each factor equal to 0, and solve. You guys can still see the answers right up above. Here's number 38. Finding the possible zeros, you're allowed to use your calculator to graph, and the actual zeros did all end up being in the list up above, if you were to actually use your zero feature. Tomorrow on the test, you are able to use your calculator. Make sure you bring it. But in order to get partial credit in case you get a multiple choice wrong, or in order to get full credit on the long answers that are worth double the multiple choice, long answers are worth like around 10, 8 to 10 each. Multiple choice are around 4 or 5 each. So in order to get all the credit on long answer, you have to show me how you get it, not just the answers. So have your calculators, know how to use your calculators, but also know how to do it by hand. 68 was kind of funny. It was actually easier than some of you might have thought. Now the wording was really weird in 68, I think, if I remember right. But long story short, he's a difference of squares. And that's how you get the first one. I don't have like an ABC. He was a difference of squares. You could actually go a little bit further by factoring this guy to be y minus 4, y plus 4. This is weirder, though, with the plus or minus 4i. But just remember, guys, you can always find the zeros by setting equal to 0. Setting this one equal to 0, you get plus or minus 4, which is where we get our minus 4 plus 4. This one equal to 0, wouldn't you get y squared equals negative 16? How do we solve that?
Square root.
Plus or minus square root, right. Plus or minus square root. Y squared equals plus or minus, how do we rewrite, how do we simplify this imaginary number?
4i.
Yeah. The I is where the negative under the square root comes in, and the 4 is just the square root of 16. Then you can take your plus or minus 4i and make little factors out of them. Does that make sense? Factors say I'll take all the zeros and I'll do y minus each of them. Y minus a positive 4, y minus a negative 4. Y minus a positive 4i, y minus a negative 4i. There we go. Number 96. These ones are the ones that I told you guys. Was he the only even? Okay. At the very, very end of homework, I said there were these tests. But the tests, the Descartes rule of signs, and then the upper and lower bound rules, they are not on the test tomorrow. You don't have to memorize them. I just was seeing if you could follow the example in the book. Number 96 just said, do synthetic division, and based on what you saw, it actually fulfilled the test requirement. A, you could say yes, because all of the signs after doing synthetic are positive, and the number was positive, the 0 was positive. B, you could also say yes, because the 0 was negative and the signs alternate. That is the test, but once again, the skill I wanted you to practice was synthetic division. The test is just this extra kind of cool thing to narrow down super long lists of possible zeros, like, what was a super long list? This one has a super long list of possible zeros. It could have helped narrow down which ones to do, but you're not going to need that for the test, okay? Section 2.6. Rational functions. Number 2 is a vertical asymptote. Number 8, they decided to do the table way, which was okay, it wasn't bad. They did the table way. Coming from the left, this would be from the left, my function is approaching negative infinity, or they would say decreases without bound. And coming from the right, they would say the function, here's from the right, is approaching positive infinity. Let me go ahead and write that though the way that we said it. So from the left, from the right, and this is for, there were 2 different vertical asymptotes. This is for the vertical asymptote at x equals -2, and at x equals +2, we could say, I'll just say left and right. From the left, from the right. From the left of +2, it's approaching negative infinity again, and from the right of +2, it's approaching positive infinity. But guys, did you have to use tables to do that? You could have just plugged in like -2.1 or -2.01. The sign would have been negative. And you could have just plugged in -1.9 or -1.99. The sign would have been positive, and that would have been enough to show. This question was on behavior near vertical asymptotes from section 2.6. Now, number 12. If you guys want, you can put a little star by this one. This is a great question as well. Taking your function, now they rewrote it. You don't have to rewrite it. You could, you don't have to. Domain, all real numbers but set the bottom equal to 0 and solve. You get -3/2. They say except, you could also just say x does not equal. Trevor.
Okay, so your vertical asymptote always be your domain also?
If, or after you've canceled out the wholes.
Okay.
But this one, is there anything that can reduce if I group them? No, they're not the same. So therefore, yes, that will be a vertical asymptote. So after you factor and simplify, vertical asymptotes are any denominators that are left. The zeros can be denominators.
If we didn't put the domain, is that wrong? They didn't ask for the domain, I think, in the question.
Oh, then you're probably okay. But I liked that it put domain, because maybe there's a place where it asks for domain on the test.
Oh, okay.
Okay. But I didn't put that, they did, so it's okay. Vertical asymptote at -3/2, which would imply, Kelvin, that the domain is x does not equal -3/2. So it's kind of implied. Horizontal asymptote, how on earth did they get -7/2?
Because the top and the bottom
Yeah,
are the
David and
same.
Goliath, pick the strong guys to go out, right? And if you take the fraction of just the strong guys, the x's cancel, don't you have negative 7/2?
Yes.
Perfect. And what did they say in their little like degree? They're just saying it's a tie, that's why. They're just saying it's a tie. Keep going. 22 is one of those sketching ones. So following my steps, I would have said factor and simplify. Long story short, you can't cancel out anything. They rewrite it by multiplying top and bottom by a negative, but it ends up being the same either way. The x-intercept ends up being a third. The y-intercept ends up being y equals 1. Vertical asymptote, since it didn't cancel. X equals 1 is the vertical asymptote. Horizontal asymptote, how come 3?
Because 3 is.
They're tied. So negative 3 over negative 1. They decided to do a few extra points because they weren't quite sure that all their clues helped. Because when you go to graph the y and x-intercept, maybe that's enough to tell you, oh hey, after you graph the asymptotes, that one's going down, but it was kind of like the one that we did yesterday. There weren't quite enough clues. So they went ahead and got a few more. What's going on at 2? What's going on at 3? Then they were able to say, oh, it's going down. Okay, I get it. And how do we find the x-intercept again?
Plugging in 0 or
Plugging in
y.
y equals 0, right? Plugging in y equals 0. And how do we find the y-intercept? Plugging in
0 for x.
If we plug in 0 for x, we just get 1. If we plug in 0 for y, did you guys grapple with that a little bit last night? How would you solve for the 0?
I'll multiply 1 minus x
And when you
on both
multiply that up, what happens when it's 0 times anybody?
sides. It cancels.
Okay. So that ends up just being 0. And then subtract the 1, divide the negative 3, that's how you get 1/3. Does that make sense? So x-intercept set y equal to 0. Y-intercept set x equal to 0. Yes.
So basically when you do that, when you find the x-intercept, you're just setting the top equal to 0.
Basically. Good. If you were a starring or a highlighting person, you might want to highlight or star number 22. It's a really good problem for tomorrow. I think something was weird with the matching in the back of the book. I don't know if you guys got 43 and it was
Yes,
different.
43 is
It was
B. Or
weird.
A, 42 is A.
Okay, I think they messed it up in the back, so that's why I went ahead and typed it out. So it should be A and then C and then B. I think there was some sort of weird typo in their answer key. So it should be A and then C and then B. This was just me typing, that feel like doesn't have all the extra, they usually try to explain why. And then was number 60 the last one? Oh, there was some true false. Yeah, you're right. Number 60. This is the last one that we did, the last type of problem we did yesterday with the asymptote that's slanted. The top wins by 1. So what they did, first of all, is they went ahead and they could have tried to factor, but if you guys tried it, the factor doesn't work.
Oh, they did division.
It's nasty. So they did division to simplify it. That's what they did, and they were able to, from the division, ignore the remainder, and the slanty asymptote or the oblique asymptote is what's left over, ignoring the remainder. That's in my notes. The vertical asymptote is from the denominator because it did not cancel. The domain's everybody but that denominator. If you guys tried to find the x-intercept, it actually doesn't work. That's imaginary if you try to solve. You can't factor, and quadratic formula ends up being imaginary. Complete the square ends up being imaginary. But the y-intercept does work. If you plug in 0, all the x's go away, and you just have 5 over negative 2 or negative 5/2. No horizontal asymptote because who wins? Top wins. No horizontal asymptote, top wins. Now they went ahead and tried to find some extra points. Long story short, after you graph your vertical and your slanty, all you really needed were just a couple points. And this one gave us 0 and negative 5/2, so maybe you were able to okay, it has to somehow fit in there. And if that one fits in there, I bet this one fits in there also. So maybe you could have guessed it even without the table. Remember I said the table's optional if you can't figure out how to sketch inside. Okay? Technically, between these two problems, the two big old sketching ones and the evens, I would say 22 is the better one. That's why I had you star it. But this one's good for finding a slant asymptote if that's asked. Okay? Last but not least, true, false. True. Where's the vertical asymptote at 1? The horizontal asymptote at 2 means the degrees had to be tied. If the bottom one, it should have been 0. And the bottom one is false. Ratio of leading coefficients must have been 2. All right, perfect. Are there any quick questions on homeworks 2.5 or 2.6 that you want me to talk about? Trevor?
Number 13.
Number 13 on 2.6?
Yes.
Cool. Anything else?
Number 33.
On 2.6?
Yes, and is it say more or no?
Let's start with those two and then we'll see how we're doing. Number 13 was just how to find vertical and horizontal asymptotes. Let me zoom in just a little bit so I have a little more space to write. 13. Okay. Vertical asymptotes. The very first thing you should try to do is factor and see if anybody cancels. Difference of squares. It doesn't match. There's no x plus 1 or x minus 1 up top. So since it doesn't match, there are no holes, and both of these will be vertical asymptotes. Vertical asymptotes will be at any places in the denominator, any zeros of the denominator that don't cancel out. So there's going to be a vertical asymptote at both positive and negative 1. Horizontal asymptote question, who wins?
Top.
The degree at the top is stronger. Top wins. What do we say about the horizontal asymptote?
Wait, what?
It's undefined.
Isn't it 1 degree higher?
There's a slant asymptote,
Yeah.
but not a horizontal, and all they ask for is vertical horizontal. Does that make sense? There's only a horizontal if the bottom wins at 0. Or if there's a tie, take the two strongman ratio of their leading coefficients. So there is a slant, good, but there's not a horizontal. A slant is going to be a different one. You have to do long division to find them. Does that make sense? Cool. Number 33. Ooh, what were the directions on that one, Kelvin? Sketch? Ooh, everything, huh? Okay, let me go ahead and take number 33 then. That's actually a really good example. I'm going to take a picture of him and move him into the notes. Oh my goodness, hi computer, let's go. All right. Remember I had you guys star number 22 in your homework check? This one's a lot like number 22, so let's use him as our last example of sketching a rational function for today, which basically reviews everything from 2.6, besides the slant asymptote because the top does not win by 1. Okay, so domain. Well, yesterday, my advice to you was the very first thing you should try to do, good, factor and simplify if possible. Do you guys see the difference of squares?
Yeah.
On the bottom, some of you might need to think about factors of -5 to add to be -4, but it does end up being x minus 5.
Couldn't you just back to the bottom or no?
Yeah, I was just showing for those who get stuck on factoring. Can't I cancel out?
Yeah.
Let's get rid of the hole. Remember, we are not focusing on holes. We're trying to get rid of them by factoring and reducing.
Domain can't be -1.
Technically, yes, we would need to say, well, we technically say x cannot equal 5, but when we're looking for vertical asymptotes,
Oh.
remember we can kind of ignore the hole. We can kind of ignore the hole because that wasn't the point this section. So when we go to find our x-intercepts and y-intercepts, we'll get to that in a second. We're going to set somebody equal to 0 and solve. But our vertical asymptote, you're totally right. The only one left over is x cannot equal -1. X-intercept, set who equal to 0?
This is y.
The y equal to 0. And Trevor actually kind of already helped us out because he said, well, if you set the y equal to 0 with a fraction and you always multiply up and it always disappears, it's the exact same thing as setting just the numerator equal to 0. Now guys, why am I just writing x plus 5 when the numerator was x squared minus 25?
Because the x minus x canceled?
Yeah. I'm looking at this guy for the remainder of the problem. I'm looking at the simplified one for the remainder of the problem. So if I set this guy equal to 0, the x plus 1 multiplies up and disappears, I get x equals -5. So I have the point negative 5, 0. The y-intercept, I set x equal to 0. 0 plus 5 over 0 plus 1, wouldn't that just be 5? Side of the point 0, 5. Vertical asymptote at x equals negative 1. How do I do horizontal asymptote? You can do it here or here. Top wins, bottom wins, or top? Top. And whether you take the strong men from the original or the strong men from the simplified, either way, what ratio do you get?
It's still 1.
1.
It's just going to be a 1. It's a y equals 1. Now, at this point, we're going to ask ourselves, do we need a table? Maybe the answer is yes, maybe the answer is no. Let's graph what we have first and see if we need one or not. I see the point negative 5, 0. 0, positive 5. I see a vertical asymptote at negative 1. A horizontal asymptote at y equals 1. Now, if you want, you could right now plug in negative 1.1 and negative 0.9 and ask yourself, is it positive or negative? Is it supposed to be going down from the left?
It's down.
No, it's
Or
going,
up?
it's going down.
Or is it supposed to be going down from the right or up? But some of you can already tell from the asymptotes, it seems to be like this one needs to go down. Because it needs to get closer to this one. Well, it must then be going this way. And then this one seems to be going. If you checked by plugging in 0.9, it would be a positive number, means it has to go up. If you checked at negative 1.1, it would be a negative number, which means it has to go down. But another way to double check is you could have made a little baby table and said, you know what, I would love to know a couple more points. And I bet maybe just one more would have helped, maybe like negative 2. And maybe like, we already had 0, maybe like 1. And if we had plugged that in, negative 2 would have been 3 over negative 1. Maybe that would have been enough to tell you to go down if you didn't know otherwise. And if you had plugged in 1, that'd be 6 over 2, which would be 3. Maybe that would have been enough to tell you to go down. All right, we walked through one whole one, like number 22 in your homework. Here's number 33. Great practice. Once again, I said that's a great problem to star and look at for tomorrow. Calvin, was there another super important one?
Number 45.
Oh, okay. Long story short on 45, I don't think I really need to show this one. Because if we were doing f of x, what would I tell you to do first? If we were even working with this guy.
Find the domain.
Find the domain. True, x cannot equal negative 1, but I'd also tell you should factor and simplify. How is this one and that one related?
They're all
They're the
the
same thing, except this one, technically, x is not supposed to equal who?
negative 1.
Okay, so they're the exact same thing, but this one says, oh, but actually there should be a hole at negative 1. That was basically the whole question. Factor and simplify. Okay, kiddos, I'm going to go ahead and, you might have some other questions. We leave that for the end, just because now we should talk about the test just for a little bit. Test tomorrow, I have already said you are allowed to use your calculator. I'm going to pull up the homework sheet. Remember, section 2.7 is not on the test. Okay? But is there still a review that would be really important for you guys to work on? I would say yes. Remember, no directions, no problems for the review. You're just practicing. I have chosen all odds, so you can look in the back of the book and on CalcChat. Except, hold on, pause. Don't do or even think about 59 and 61 because they're from section 2.7, the one that we're skimming. All right? So don't worry about 2.7 for right now's homework. That's not due in the homework spiral. And don't worry about 59 and 61. Now, here's what's going on in the test review. All of this is from sections 2.1 to 2.4. There's a lot of information in those sections. Okay? These ones are one big problem. Well, almost each. I think 2.5 has two big problems. But a big problem from each of 2.5 and 2.6 that make you review everything from those sections, like what we just did with the graphing. So number 53 is a lot like what we just did together, number 33, and number 22 that I had you start. It makes you review vertical asymptotes, horizontal asymptotes, factoring, domain, all that stuff in sketching. 41 and 43 make you review when you're given a nasty polynomial, how do you break him down to factor and find the zeros? Guys, those are the huge ideas from everything that came after your quiz. If I were you, grab out your quiz real quick. I think a couple people said they might have questions on it. The quiz went over sections 2.1 to 2.4 very briefly. The review, I gave you more problems to help you with the ins and outs of end behavior and complex numbers and simplifying when you divide or multiply imaginary numbers, polynomials and factoring. Do we have any questions on the quiz? Yeah.
Yeah, I didn't get it back.
Ooh, can we hand that to you?
Get yours.
Oh, that's right, you guys were all supposed to get it. I know, we handed it out.
Yeah.
Kiddos watching the video, I will bring the quizzes home with you tonight, so if you realize that you don't have it and you want to look at it before tomorrow, feel free to email me, and I will send you a picture.
Oh, what you're saying, do we turn in the quizzes?
Oh no, you can keep it to study from, we're not even gonna even do like formal corrections on it, the rest of you guys got them, I think, right?
Yeah.
I'm just letting the other people know, let me put it back in my backpack. They can come in after school, but they won't have watched the video yet. If you guys see anyone in pre-cal, be like, hey, go get your quiz. But I let them know I'll take it home with me tonight. If they don't get it from me today before I leave, that way they can still see their quiz and study from it before tomorrow. All right, kiddos, any questions on the quiz?
Can you do number 1?
Uh-huh. If anybody else, if your quiz is pretty good, you can go ahead and, let me do this. Write down the test review problems, and if you want to get out a book and look at those test review problems and see if there are any that you don't know how to do, you can ask me those questions and we can go over those as well. Let me see if I can zoom though. Can I zoom? Well, kind of zoom. There we go. There we go. All right, so number 1, the problem was change to standard form. Ooh, that's a good one. There we go. There's the review if you guys need to write it down. The quiz gave us a function and said, change to standard form and identify the vertex. Kiddos, from section 2.1, one of the most important things to know how to do is to find the vertex, aka to change to standard form. You don't have to use completing the square, you can use the formula way. But remember, standard form is going to be y equals a times x minus h squared plus k. That's what you called vertex 1 last year. And the vertex is, okay, so if completing the square, and you never got it down, couldn't you use,
Negative.
exactly, h is equal to negative b all over 2a, which in this problem would be negative negative 9, as long as it's written in ax squared plus bx plus c. If it's not, rearrange it. Negative negative 9 over 2 times 3, right? Which would be a positive 9 over 6. H was equal to 3/2. How would you have to find k if you're using the formula way? You'd have to plug back in and say y is equal to, which is the same thing as k, 3/2 squared minus 9 times 3/2 plus 2. Kelvin, what's that then?
Does negative b over 2a work all the time when you want to find the vertex?
Yes, the struggle is this plugging in can mess up a lot of people, but it does always work.
Subtraction. Oh,
But it does always work, just go carefully.
okay.
And this one, we'd have to get some common denominators.
4.
Yeah, I'd multiply everybody by 4 over 4. This guy already has an over 4, so we'll leave him. He would be 54 over 4, multiplying top and bottom by 2.
8.
And he'd be 8 over 4, which ends up being 17. And 54 does it end up being?
Wait, what?
9 times 3 has plus 2.
American
Ooh, hold on, I didn't plug in correctly, that should have a 3. That makes more sense.
Oh,
It should be 3x squared, right?
Yeah.
oh, it's 27.
There we go. So that should be 27 over 4. And 27 minus 54 is a negative 27 plus 8 ends up being a negative 18 fourths. Now, this is how you can find the vertex using the formula method, but you would still need to, in number 1, write the standard form. So to write standard form, you could take these off to the side and do y equals, who's A? 3. Times x minus who? H.
3 squared,
Plus who?
negative.
Okay.
Can you write minus instead of?
Yeah, you could write plus a negative or minus.
Wait,
So those were the answers I was looking for in number 1.
So your A value is always gonna be your mean, whatever.
Yeah. If you were doing completing the square instead, all that would change is you would have needed to factor out the 3 first. Then you would have had to cut that 3 in half, stealing the sign. Well, I shouldn't put the blank. So when we come down, we cut the middle in half. Hey, we already found the h. And then how do we come back up?
You have to add it.
You have to add, but add what? Not this.
That's squared.
The square of that, which would be 9 fourths. The struggle is when you look to the outside, that's really a 27 fourths. And so you would end up with 8 over 4, which is 2 changed to a common denominator of fourths, minus 27 over 4. Maybe you guys notice that you end up with the exact same thing. And then you would have had to look at this and say, oh, it's x minus h, so h is 3 halves, and it's plus k, which is a negative 19. Do they both get you the same answer? The answer is yes. 2 different ways, and both ways are good. Benson?
Basically, you gave me version A yesterday, so I don't have version B like honest.
True, but the questions are very similar, so if you understand how to do it this way.
No, I just want the just a piece of version B. Sure, just
Oh, to look at?
Yeah, look at it.
I'll give you a grade. I'll show you graces, but you got over 100.
Which one did you get?
Okay. Is that okay? Are there any questions on the quiz that you guys are wondering about? Long division, and number 4, a lot of people miss that one because
Before you have to take what you got from.
I said find the value, and the value is the same thing as the remainder. So you were supposed to do synthetic division and get 1, 3, negative 18, x squared plus 3x minus 18, but the remainder is 0, so f of 3
Oh, I forgot to
equals
balance it out.
0.
What?
That's what I did.
Now, it was worth 2 points. If you did correct synthetic division, you got 1 of the points, but if you didn't answer the question, I had to take off 1. But the nice thing is on the test, I think I just say find the value, so you don't even get confused with how you find the value. Some people plugged in and found the value, but I had to take off a point with no synthetic division. And then other people did synthetic division and didn't use the remainder as the value.
So the value is x minus 3?
No, the value, the factor is x minus 3.
Okay.
The value is when you plug in 3, you get out 0, which is seen by synthetic division, the remainder being 0. That's the remainder theorem from our notes in section 2.
And then if you want to check, you plug the 3 back in
Yeah.
to what you got.
Yeah, you can double check and make sure you
Wait, for the bonus one, did you give us the factor?
Yeah, I gave you x equals 1, so I gave you a starting point. But from that starting point, it's actually a great question. A lot of people
Can you
didn't
do
know
that
how to
one?
keep going.
No,
I mean, that was just
be
the
happy
concept.
2.5.
Yeah, it was basically 2.5, and so I gave you the clue to make it like 2.3. So when I gave you x cubed minus 10x squared plus 29x minus 20, and I gave you a hint in class, use x equals 1, I told you where to start. So some people, when they, did anybody do synthetic?
I did.
Yes.
Okay, when you plugged in 1, with 1, negative 10, 29, and negative 20, you should have gotten a remainder of 0, because I gave you a good hint.
Yes.
My question is, what was left?
Back.
Negative 9.
20.
Now, if I wanted you to factor completely, you would have needed to take that x minus 1, the factor from the 0, then take the x squared minus 9x plus 20 and keep factoring.
Oh my god.
Because then you would have x minus 4.
Minus 5.
So if I wanted you to factor it, those are the factors. If I wanted you to find the zeros, you would have gone one step more and identified all of the zeros. Yeah.
So for splitting division, you're basically just like adding, right? So like negative 10 plus 1.
Good. Well, you bring down the 1 first,
Yeah.
but then you multiply and then you add down. Good.
And then 29 plus negative 9?
Mm-hmm. Which is your 20. And then negative 20 plus 20 is 0.
Oh, okay.
Does that make sense? Good. All right, kiddos, those are great questions from the quiz. And to believe it or not, if I just took away this hint, this would be section 2.5.
Yeah.
If I took away the hint, this would be section 2.5. Just you guys would have needed to think about plus or minus to figure out how to start
1 over
testing,
20?
so you wouldn't know that. You would do factors of 20 over factors of 1. So 1 and 20, 2 and 10, 4 and 5. But do you think maybe we would have started with the 1?
Yeah.
No, that would have worked out really nicely. What if 1 did not work? Maybe try negative 1. If that doesn't work, maybe try 2. I'm not going to give you one that's super far away for the first 0. Now remember, you can try with synthetic. The remainder needs to equal 0. But if you're good at mental math, what else could you try first? You could plug in. And 1 minus 10 plus 29 minus 20 does equal 0. Before you ever do synthetic, you'll know it works. Try it.
Okay, so are you gonna give us like a hint, or are we gonna have like 5 or 10 subjects in there?
If you have any factor completely, find the zeros completely. If it's multiple choice, I'll probably give you a hint. And if it doesn't have a hint, there's probably only 1. And it could show up in the multiple choice or the long answer. Yeah. But if there's any without a hint, probably only 1. Unless like the question is something like find all the possible zeros and I don't even make you finish the problem, something like that. Kelvin.
How many questions are on the test?
There were supposed to be 20. I miscounted, so there's actually 19. And then 2 of them are being taken off. 1 long answer and 1 multiple choice need to be removed because they're from section 2.7. I didn't replace them because that gives us like maybe 5 minutes at the beginning of class for those who aren't here today to be able to ask me something last minute about vertical asymptotes, horizontal asymptotes, whatever that they got stuck on in the review.
And this is multiple choice?
Multiple choice will be 15. There's technically 16, but when you do cross, tomorrow you'll get the test and you'll literally cross off 2 problems that you shouldn't do. And I won't even look at, I won't grade whether or not you get them right, I don't care. They're 2.7 we're crossing off. So there's going to be end up 15 multiple choice and 2 long answers.
Okay.
Yeah, try.
You can do another problem.
Yeah.
Which one? Section 2.5 and 21.
Okay. Anna, you had a question too, kiddo. What's up?
Yeah, for number 5, I like multiplied everything,
Good.
distributed, but then I didn't know how to continue from there and do it on my paper simplified.
Ah.
But I didn't know what.
Here's why. When you foiled, you should have gotten 15. You might have had this in a little different order, but plus 6i minus 5i minus 2i squared.
Yes, exactly.
Look in your notes for 2.4 also. But whenever we multiply, we combine any like terms we can, which will end up being a positive I. But the dilemma is, what do we know about I squared?
It's -1 and -1.
It's negative 1. So that'd be 15 plus I plus 2, which would be 17 plus I. And we cannot combine anymore because that's real, that's imaginary, they must stay separate.
But isn't I, 1i, negative 1?
Ooh, nope, careful. 1i is the square root of negative 1, and we can't rewrite that any other way. I squared takes that and squares it, which is why we're able to write negative 1. I cubed is a combination of the 2 above, and I to the 4th is the one we really like, because he's just
It's just 1.
a negative 1 times a negative 1. So I would look over the powers of I in section 2.
Oh, okay.
I would look over the powers of I. And in section 2.4, what wasn't on the quiz, doesn't dividing get tricky? You have to multiply top and bottom by an I or by a conjugate. You might want to look at division.
To match it up.
Yeah, to match it up to simplify. Section 2.5, for those of you that didn't hear, Trevor had a question on one of the homework problems, and we're gonna go ahead and peek at that, if I can find it. There we go. Number what? Number 20? Okay. Number 21 says find the rational zeros. That means basically figure out which ones work. Rational zeros come from, that's 21, right? Remember, the rational zeros come from the factors of the constant over the factors of the leading coefficient. The constant, exactly, of 4 is 1 and 4 and 2 and 2. You can do synthetic division to check, or you can do plugging in to check. What I would do is probably do plugging in with, like, 1 is easy to plug in usually, so 1 minus 4 minus 1 plus 4. Well, that cancels, that cancels. You get 0, right?
Yeah.
Okay, well, if you get 0, then I know that this one does work. You have two options. You can either say, check, plus 1 is, but I'm looking for up to 3 more. You could try -1, +2, -2, +4, -4, plug them all in. Any of the ones that equal 0 work. Or you can do synthetic division with your 1. Be careful, if there's any missing terms, put a 0. So as you go to solve, you can go ahead and rewrite this and define the other ones. Maybe it'd be way easier than plugging in all these other ones and testing them to just factor, if you can, whatever's left. You end up with x
Minus 4.
and x plus 1.
Yeah.
And that's how you can find all of your zeros, because now you said each one, right? Each one equals 0. So just,
Oh yeah, -1, yeah.
-1, 4, and -1.
No, the x minus 1, because in a sense.
oh, I
your
didn't
thing-
write that,
Yeah.
thank you. That was close. It's dangerous, you have to do x minus whatever the 0 is. You let them out earlier in that kind of class. So you go ahead and solve. +1, +4, negative. You found all the zeros.
Okay.
You guys have any other
Wait,
different
can we
questions?
actually do that by grouping?
In this one, yes, but not always. I showed it, I think, once or twice, once in notes and once in homework. This one you could have done grouping, but just a warning, if that's the only way that you know how to solve, you'll be in trouble, because grouping only sometimes works with the big ones. Like in the next problem, it won't work. You have to use what I showed. So what are you doing tonight? Just working on the review. Okay, remember, don't do the last 2 problems. Working on the review. Studying notes all the way back from section 2.1. Is the quiz good to study?
Yeah.
Yes, if you see friends who weren't here today in class, be like, go get your quiz, it'll be helpful to study, she went over it in class. You can watch the video again in any of the examples that I did, and did I even have you star some important problems that might be good to especially look over?
Yes.
But did we talk a lot about sections 2.1 to 2.4? I don't know. Look over the leading coefficient test in the odd, positive, negative, the even, positive, negative, the end behaviors. Look over the vertex form again from section 2.1, maybe completing the square if that's the way that works, but find one that works for you, plugging into the formulas, or completing the square. And look back at your workspace and your homeworks. Find things that you got wrong and double check that you know how to do them now. Kiddos, real quick, on your homework class review. Number 9 is beyond what is on the test tomorrow. So if you want to play around with number 9, you can try it real quick just to get credit, but number 9 you do not need to fully understand for the test tomorrow. Sound good? So if you want to take one more picture, number 9, try it to get credit. It is a good problem, but it is harder than the test will be. It has to do with like a rectangle and perimeter and area. It was like homework, but it's not the geometry, but it will not be on the test.
Step 110,
You know your stuff? Like, and if the review is pretty easy, it should fall like this. But if you don't study,
Do we need to know a lot of 2.2? Do we need to know a lot of what is on 2.2?
2.2 is like sketching polynomials and the end behavior factoring. 2.2 was actually nicer than 2.3 and 2.5 because the polynomials are prettier. You know what I mean?
Yeah.
So I think 2.2 is actually pretty good. The majority will probably come from 2-2, 2-3, 2-5, 2-6. But 2-4 has some complex numbers, and those are nice problems as long as you simplify properly and study the division. And 2-1, there's gonna be a couple problems on vertices or standard form. Does that make sense? Okay, any other questions? You guys know what to do? Bring your calculators tomorrow, spread the word. And if anyone's like, why is she having the test, remind them, you don't wanna have to squish it in half day on Friday. That would be awful. You want time to work out synthetic division, log division. If you make a mistake, be like, oh, I need to go back and try it again because I messed up a seal and didn't treat it. Kiddos in development, I'm good for you to go. I love how they're all just standing out there. A little crazy. Oh, I know why they're standing out there. Actually, you guys go ahead and go.
Okay.
They're trying to get ready for naps and nuggets. No Santo. Bye, everybody.
Thank you.